So in this video we're going to be looking at solving multi-step equations. We're only going to focus on the variable being on one side though. Alright, I'll make another video where the variable's on both sides. It's not really much different. There's just some extra explaining to do. So let's go over some steps. That way we can at least have a roadmap of how to go about this. So the first step we're going to do is distribute. Alright, now with each of these, you can also say if necessary. Obviously you can't distribute. I'll abbreviate this. You don't want to distribute if there's nowhere to distribute. Pretty much what you're looking for is parentheses. If you see parentheses and there's a number right out in front of your parentheses, you're probably going to have to distribute. All right. Step 2 is going to be combine our like terms. All right, so combine like terms, which I think that needs a hyphen actually. Let's do it just to be tryhards. All right, so combine like terms. Now, I'm going to explain this in a second just to give you a quick overview, but just remember like terms have the same variable and exponent. I'll write it out in a second. Let's go over the last step. All right, then the last step is just to solve. Because if our variable's on one side, then we don't have to move our variable. All right, so let's talk a little bit more real quick just about combining like terms. Just for a second, I won't bore you to death. So when we combine like terms, so combine like terms. If you haven't been over this, or maybe you just need a refresher, you might be asking, what are like terms? What does that mean? So you need two things to happen. You need the same variable, so same variable, which we know is just a letter, and then we need to have the same exponent. So same exponent. All right. Now, I'll probably have another video just doing some examples of this, so be sure to go check that out if you have a little bit of trouble with combining like terms. All right, so now let's actually do some examples, because a lot of this video is going to be example heavy. So let's just call this, we'll call this number 1. Who cares what we call it, honestly? Let's not even number it. Who cares? All right, so 9x plus 1 minus 7x equals, actually I left one part out, minus 5 equals negative 20. All right, so once again, let's go through our steps. So step 1, we have to distribute. But if you look, and honestly, what I would do, I would use this trick, which you've seen me do in other videos. We want to know where our left and right side of our equal sign is. So an easy trick, draw a line right at the equal sign. Now we can see the left and the right. So let's look on the left side. Do we see any parentheses or anything that needs to be distributed? I mean, I don't see any parentheses, so let's just assume there's no distribution. So let's move on to the next step. Step 2 is combine like terms. So do we see any like terms? Now remember, we need the same variable, same exponent. So let's start with 9x. I'm going to underline that once. If there's a like term, I'll underline any like terms one time. So is there another term that has x, and technically it's x to the first power, but we'll just say x. So you'd probably say yes. 7x has an x in it. So those two are like terms. Now, be careful here. You want to pay attention to the sign to the left of 7x. Because technically, if we combine these like terms, we would say 9x plus negative 7x, which is also just the same thing as saying 9x minus 7x. All right, so if I do 9x minus 7x, it's going to give me 2x. Because when you combine like terms, the variable doesn't change. So when you're adding and subtracting and you have like terms, the variable stays the same. All you have to do is look at the coefficients and say 9 minus 7, and then you're good to go. You just have to make sure you don't forget to bring down your variable. All right, so let's get rid of some of this. That way I can actually make it look a little bit nicer. All right, so boom, boom, we said 2x. All right, so now here's another trick you can do. When you combine like terms, go ahead and cross out what you've already used. That way you don't accidentally, by mistake, reuse something. All right, so now we need same number, same variable. Now, if something doesn't have a variable, like this positive 1, it can combine with minus 5 or negative 5, because that would be like I gave you a sheet of paper and said, hey, do 1 minus 5. It's the same thing. So numbers will always be like terms. It's not going to be a like term if you add in a variable. So now 1, then we have 5, but it's negative once again. So once again, that's like saying 1 plus a negative 5, which is just 1 minus 5. So that would give me negative 4. So right now I have 2x minus 4, and then I'm going to bring down my equal sign. Now, on the right side, we only have negative 20. There's no like terms with negative 20. There's literally only one term. It's negative 20. So negative 20 just comes down. All right, so now, this essentially now becomes a two-step equation. Once we do the distributing and the combining like terms, you're either going to be left with a one-step equation or a two-step equation. So now we have a two-step equation here. We have 2x minus 4 equals negative 20. If we draw a line at the equal sign, you'll see that x needs to be isolated on the left side. We need to get that x by itself. So 2 and minus 4 need to go. Which one needs to go first? You always want to, except for one case, you always want to get rid of the adding and subtracting first. So we want to get rid of minus 4, so how would we do that? What's the opposite of subtracting by 4? It would be adding 4. And then we want to balance our equation, so what we do to one side, we do to the other side. So now 2x, this is going to cancel, equals negative 20 plus 4 is actually negative 16. We're making negative 20 less positive, and this one, I mean, it's a little confusing to do, but just try your best, and we'll call it a day. All right, so now one last step, and then we're finished. So now we have x on one side, on the left side, but now there's still a 2 here, so let's get rid of 2. How would we get rid of 2? If we have 2x, what's that really mean? This is 2 times x. So if we want to do the opposite operation, we're going to divide by 2. And then I would go back and double check to make sure that's a positive 2. It is, so we're good to go. All right, so now I'll just finish it over here. All right, so now we have x equals negative 16 divided by 2. Negative 16 divided by 2, we would say a negative divided by a positive is negative. 16 divided by 2 is 8. So x equals 8. All right, so let's do another example. Let me see here. Let's just do 91 equals negative 7 times 3a. Let's change that to x because we have a 9 in the problem. A lot of times my a's look like 9s. All right, so let's say 3x minus 1. All right, now, if you feel confident, pause this. See if you can go ahead and do this one by yourself. So remember the steps. First, we want to distribute. So let's look at both sides of the equation. Left side's just 91, so we're good to go on that. That's already good. Okay, equal sign comes down. Now, we do have parentheses, and if you have any adding or subtracting or multiple terms in your parentheses, you're going to have to distribute. All right, so we're going to distribute negative 7 to 3x. So we're going to multiply negative 7 by 3, and then we're just going to bring down this variable. So negative 7 times 3 is negative 21, and then we're going to bring down x. So we're going to multiply our numbers and then just bring down our variable. Now, this is where a lot of people get tricked. When I do negative 7 times this 1, a lot of people are going to say, well, that's minus 7. So 7 times 1 is 7. That's correct. However, that minus sign in front of 1 actually makes this negative 1. So it's negative 7 times negative 1, which is positive 7. So be careful of that. It takes a little bit of practice and attention, but I think you could probably handle it. All right, so now let's combine like terms. Let's look on the left and the right. Let's see if we have any like terms. So once again, the left side's still just 91, so we're good on that, which I don't even really need to rewrite that. All right. On the right side, we have negative 21x. This 7 does not have an x. Therefore, these two are not like terms. I can't say a term with x plus 7 gives me anything. They're just going to be written like they are. So we get to skip step 2, which is combine like terms, and we get to go straight to step 3, which is solve the problem. So now we need to isolate x. So what needs to move? Negative 21 and 7. Which one do we want to move first? In this case, there's not one big fraction, so we want to get rid of plus 7 first. How would we do that? We would subtract 7. And we would do it on both sides because we want an even or a balanced equation. So 84 equals negative 21x. And I hope you have a calculator because I would not want to do this last part in my head, but you can if you need to. All right, so then lastly, we need to get rid of this negative 21. Once again, if you see a coefficient and a variable, those are multiplied, so the opposite operation is dividing. Now, I'm hoping you're noticing a mistake I'm making, because a lot of people would do what I just did, and they wouldn't catch what their mistake is. What's my mistake? My coefficient is negative 21. I divided by 21. So make sure you double check that you are accounting for any negatives that are in your coefficient. All right, so those two will cancel. 81 divided by negative 21. First of all, we know that, and I can switch this around and say x equals because it's not going to change anything. First of all, a positive times negative, or divided by a negative, is a negative. 84 divided by 21 is going to give me 4. So x equals negative 4. Let's do one more just for the sake of doing it. Let me find a good one for us. Let me find one that will be a little tricky. Let's do 20. No. Yeah, let's do this one. All right, I'm going to switch it around though. Let's do 10x. I changed my mind again. I'll do that a lot. That's okay. All right, so 20 equals 10x minus 6 times 2x plus 5. All right, so see if you can do this one. I would almost guarantee a lot of you will be able to just knock this one out. All right, so once again, let's go through our steps, our process. Step 1, distribute. Do we have anywhere that we need to distribute on the left or the right? Hopefully you're saying yes, but be careful of this. We're distributing 6, but if you want to make your life easier, you can change this to addition and make this negative. Because if we go back, minus 6 is the same thing as saying plus negative 6. That way you see that I'm distributing a negative, and just from experience I'll tell you, doing this makes your next steps quicker, so I would advise you do this. So we're going to distribute negative 6 to 2x and to 5. Everything else is going to come down like it is. So 20 equals 10x. Now we're going to let the sign that's created by negative 6 times 2, we're going to let that sign dictate if we say minus or if we say plus. So when I do negative 6 times 2x, I get a negative number, so I'm going to say minus. I get negative 12x, so I'm going to say minus 12x. Next, I'm going to say negative 6 times 5, and once again, negative 6 times 5 makes negative, so I'm going to say minus. And it makes negative 30, so I'm going to say minus 30. You could also say plus negative 30. It's just better to save you a little bit of time to go ahead and let your sign dictate if it's plus or minus. All right, so now our next steps are combine like terms. So let's look on the right side. What like terms do we have? So anything that has the same variable and exponent. 10x, 12x, and if you look right in the middle, luckily these are together, you have subtraction. So what I'm really saying is 10 minus 12, which is negative 2, and then I bring down my x, minus 30, and then we're almost ready to go. All right, so let me get rid of this. That way I have enough room. I don't know why I always do this, but I always write too big, but that's okay. All right, so 20 equals, what did we say, negative 2x minus 30. All right, so now we're just going to solve. We've done our distributing, we've done our combining like terms, now we're just going to solve for x. So once again, there's two things that need to go to isolate x. Negative 2 needs to move, and so does this minus 30. Which one do we want to do first? Well, we want to get rid of the minus 30 first. We want to do the adding or subtracting portion first, except for one case. Maybe we'll look at that case in a second. All right, so 50 equals negative 2x. How do we get rid of this negative 2 away from x? We would divide. And make sure you notice this is a negative 2, so we have to divide by negative 2. So now negative 25 equals x, and we are finished. All right, and I think that's it for these examples. Maybe I'll make another video on the on another example, but there will be a video where there is a variable on both sides, so I'd be sure to check that out. There's also 1- and 2-step equation videos that you can go check out. So I would do that if you need a recap of any of those, but that's it. Let's just do this real quick in case we need to see it one more time. Steps. Solving a multi-step equation. We're going to distribute. We're going to combine like terms. We are going to then solve as long as our variable is already on one side. Okay? So that's if the variable is on one side.